All right, so let's go ahead and solve this guy here. We have dy, we have 1 in front of that, plus this function, 2xy minus e to the negative x squared, that's in front of the dx, is equal to 0. Now the first thing I want to do is you'll notice it's written as dy first and dx second. So that's actually going to change our m and n. So the first thing I'm going to do, basically, just to make all the notation consistent, is I want to make sure that I write the dx first, otherwise this problem won't make any sense and it's not going to work. And that's going to be plus 1 dy is equal to 0. Now once you write it this way, then you can see, okay, this is now my m, and this is my n. And so now we want to check to see first, is this exact? All right, so if we check exactness, then the derivative of m with respect to y, well, that's just 2x. And the derivative of n with respect to x is just 0. And we see that these are actually not the same. So that means that that tells us that it's not exact. So it's not exact. But don't worry, we have two different integrating factors we can check. So 2, we need to find an integrating factor. So we're going to find an integrating factor. And let's try the first one. If I do, remember, we're looking for an integrating factor that just has one variable in it. So if I have n sub x minus m sub y divided by m, let's see what that gives us. That's going to give us n sub x is going to be 0 minus m sub y, which is 2x, and then if I divide the whole thing through by m, I get 2xy minus e to the negative x squared. And we see that that's actually a bad choice, right? Because it has x's and y's in it. So it has x's and y's. That's the problem, is we should be able to simplify these things just to get one variable. All right, this isn't looking good, but let's try the other substitution. So the other one, I'm going to have m sub y minus n sub x divided by n. This is a little bit more promising because, well, n is just 1, right? So that's going to be a little bit easier. So the derivative of m with respect to y is just 2x. The derivative of n with respect to x is just 0, and then n is just 1, and we get 2x. So we see that this actually works. And that's what we're going to use. So that tells us that our integrating factor is going to be mu of x is equal to e to the 2x dx, which is simply going to be equal to e to the x squared. So now I multiply every single term by e to the x squared. All right, so if I multiply each term through I'm going to multiply this ODE through by our integrating factor and see what happens there. So I'm left with 2xy e to the x squared minus, and then e to the negative x squared times e to the x squared just becomes 1 dx, plus, and then if I integrate 1, by that I'm just going to get e to the x squared dy equals 0. So now I have my two terms that I had just like, and this should be exact. And again, you can check it just to make sure. To make sure that your integrating factor and everything worked. So next I'm going to actually find a function that satisfies both of these conditions. I have 2xy e to the x squared minus 1 dx. And the antiderivative of that, this first term here, I can just use u sub, that's x squared, and so then the derivative of x squared is just 2x, so that's actually pretty nice. That's just going to be y e to the x squared, and then I have minus x. And then I have a function of y. And I'll just call that function of y g. Then I also have the second term, which is just e to the x squared. And again, that's going to be pretty easy to integrate because there's no y's in there. So the antiderivative for that is just y e to the x squared plus, and now I'm going to have any function in terms of x. And now I need a function that satisfies both of these. So f of xy, it's pretty nice. They both have ye to the x squared, so I'll write that down. That's going to be equal to ye to the x squared. And what I can do to make sure that they both fit, I don't need any more functions of y, so I'll just set this one equal to 0. But you'll notice that over here I have minus x, so this little guy should be minus x to make that work out. So that's just going to be equal to minus x. So my overall function is just going to be f of x is equal to y times e to the x squared minus x. And so our general solution to this should be ye to the x squared minus x is equal to a constant to make that into a level curve. And I can solve for y by simply writing this as equal to the constant c. And if I solve for y now, that's just going to be, let's see, x plus c, and then I multiply that through by those terms there. So that's just going to be e to the negative x squared times x plus a constant. And that is what we should have for our ODE solution.